Good morning.
How was your weekend?
Oh, not too bad. How about yours?
It was alright. But I'm sad I did my hair yesterday because I was all frizzy.
All frizzy because of the humidity. All right, so we did 1 through 5 on Friday. Does anybody need me to do number 1? The answer should have been E. Yeah, we're good? Sweet. All right, number 2, the answer was H. Do we need to go over number 2? All righty. Number 3, the answer was D. Yes, we need to go over that? No? Oh, okay, you're like, yes, you got it right. Okay, sweet. I like to hear that. No, you need it?
Yeah, I need it.
Okay, oh, let's go over it then. All right, let's see. Oh, no, you're not. Company A.
Wait, yours, how do you, no.
What?
No, it's fine.
I don't need to go over it?
No, I was talking about something else.
Okay, so Company A sells 60 pens for $15. So, let's see. So we need to do 60 pens divided by $15.
Wait, why would you do $15?
Huh?
Why would you do $15 divided by 60 cents to get
Hold on. Okay, that'll work too. That'll work. If you want to do it that way, that'll work. We'll do it that way. Alright, so $15 divided by 60 pens is 1/4, 0.25, is that right? Check my math there, it's early in the morning still. That's Company A. Company B sells the same type of pens, but they're going to do $8 for 40 pens. So is that 0.2?
Yeah.
Okay, so 0.20, 0.2 either way. Are y'all okay so far? So which one is cheaper?
B.
Company B. So that means it's not going to be A, B, or C. And at 20 cents. All right, what about 4? 4 should have been H. Do we need to go over that one? That was just the Pythagorean theorem? Anybody need it? Yes? All right, Pythagorean theorem is A squared plus B squared equals C squared, where C is your hypotenuse, so the 10 is your hypotenuse. So you don't know the A squared. You know the B squared is 8 squared. You know the C squared is 10 squared. Let me show you a trick in your calculator. You ready? Okay, so you know that you're going to move this 8 by doing what? Subtracting. So look, guys, in your calculator, you just do 10 squared minus 8 squared, and it'll do all that stuff in your calculator for you. So you have A squared equals 36. Does that make sense to everybody? If that doesn't make sense to you, do it the way you've normally done it. 64 equals 100, subtract the 64, and you'll still get 36. Okay, this is just a time saver. And then what's the square root of 36? Technically, it's plus and minus 6, but since we're dealing with real life world, we can't have a negative side of a triangle, so yes, it is just 6, which is H. All right, number 5 was E. Do you remember those proofs that you did in geometry? Okay, that's all that number 5 was. Number 5 was a proof, and you should have gotten E. Do I need to go over number 5? Okay, all right, so here we go. Here's what we're going to do. Tomorrow, I unfortunately will be out. I'm sorry, guys. I am not normally out this much, but I've got some things going on that I've got to deal with, so I've got to be out tomorrow. But that's cool, because all we're going to do tomorrow is review. I'm going to leave the keys like I normally do. You're going to have a checkpoint, so y'all get to kind of do things the way you normally do, okay? So things are not going to be disrupted just because I am out. So today, we're going to finish up 8.2 notes, which is on page 5. So go ahead and grab page 5 real quick like. Page 5, page 5. All right, we're going to start on number 3, okay? Okay, so what about number 3? In order to subtract fractions, the harder ones are subtracting and adding, right? Page 5, yeah. It's only got these few problems on there, 3 to 6. Chapter 8, baby. You're in chapter 7. Okay? Alright, in order to subtract fractions, what has to happen, guys? Common denominator, right? But before we can find a common denominator, you probably need to factor some stuff. So what do you see that will factor?
3x plus 15.
3x plus 15? Okay, how does that factor?
3 on the outside and then x plus 1.
Okay, do you see anything else? Yes, somebody shut it. Anybody else see anything that'll factor? 3x minus 15. How will that factor? 3x minus 5, right?
And then 6x minus 30
Yep.
would be 6 on the outside, x minus 1.
There you go. Okay, so in order to have a common denominator, they have to be the same, all right? What's the only thing that's keeping them from being the same? The 6 and the 3, right? So what's common between 6 and 3? What's the least common denominator? 6. 6 will not go into 3. Okay? 6 will go into 6 and 3 will go into 6. So how do I make 3 become 6? Times 2. There you go. And if I multiply 2 on the bottom, I have to multiply 2 on the top. And what's that numerator that I'm going to multiply 2 by? X plus 10. And you must use parentheses, okay? Alright, so here we go. We now have a common denominator because 2 times 3 is 6, right? What do you see I can do first? Multiply what? There you go. Multiply these. 2 times x is 2x. 2 times 10 is 20. Now be real careful on the next one because the next one I'm not multiplying by 3. What am I multiplying by? Negative 3 because it's subtract, right? So be careful. So what is negative 3 times x and negative 3 times 5? Minus 15. Very good, very good. Negative 3 times 5 is negative 15. And the bottom is just 6 and x minus 5. Because remember, when you add and subtract, you don't touch that denominator. All right, do you see any like terms? What's 2x minus 3? Negative 1x. There you go. What else you see?
20 minus 15.
What's 20 minus 15? Positive or negative 5? Positive 5. Very good. Now, ladies and gentlemen, that is not wrong. That is a correct answer. However, on a multiple choice test, they're very rarely going to have a negative leading coefficient because that's not proper. So what could I do with that negative 1? Pull out the negative 1. That would leave me with x minus 5, right? So that leaves me with 6 and x minus 5. Holy moly, what happens now that I have multiplication? They cancel because I have multiplication only. Only multiplication. And that simply reduces to negative 1, 6. Do you see now why we factor everything all the way through? Yes, ma'am.
Why can't you just multiply the first fraction, or the first fraction, to get the common denominator?
That's what we did.
But you factored. Okay.
I subtracted everything when I distributed. Then once I combined everything together, then it's just 1/6. Or negative 1/6, excuse me. They won't normally do that, but the ACT loves to put problems like that, where y'all will leave it like this one, and then y'all freak out because you don't see your answer, when all you had to do was take out that negative 1, and you would see just the number by itself. Okay, what about number 4? You ready? So I've got to factor first. What do you see that will factor?
The bottom of the first one.
The bottom of the first one, x squared plus 9x plus 18. How does that factor?
X plus 2 is x plus 3.
Yep. Okay, the other one is just x plus 6. So, what is one of them missing? X plus 3. Very good. All right, now here's the thing, though. If you multiplied by x plus 3 on the bottom of this one, You gotta multiply by x plus 3 on the top. Okay, so I didn't touch the first one. I didn't do anything but factor the first one, so the top is just going to be 4x. But the second one I multiplied by that x plus 3, so it's going to be 5 times x plus 3. Are y'all okay so far? D, you okay, baby? I know you weren't here for a couple of days.
Yeah, it's like
Okay. All right, so now that we got a common denominator, here we go. So we're going to have 4x, and what am I going to distribute? A what? What kind of 5? Positive 5. There you go. So I get 5x plus 15 is perfect. And my denominator is x plus 6, x plus 3. Combine those like terms, and what do you get? Perfect, Brinkley. Very good. Now, that is not wrong, ladies and gentlemen, but you're hoping and praying that something will reduce. So, do you see something that I could do? 9x plus 15. What can I do, Gracie? I can pull out how much? 3. Very good. Which leaves me with 3x plus 5. And unfortunately, nothing will cancel. So, either one of those is correct. Are y'all okay? Got it good? Y'all think y'all can try 5 and 6 on your own? Okay, y'all try 5 and 6. Nice job, guys. Very nice. All right, Grace has number 5 up there for you. Make sure you get the same answer as her. And when I'm looking around, most of us have that same answer. Very nice job, guys. Very nice. Watch on number 6 when you finish watch. Number 6. Good job, Grace. Matthew sent us the answer for 6, but most of y'all look like you already have the right answer. Nice job, y'all. Nice job.
What happened to the lead that was with that's when you do wrong. You should have left that as back in that earlier. You got this one out. Well, that's minus 8 is correct. Which you didn't make back is back up. That's the only thing wrong.
Okay, if you're finished, see what you can do on page 6, and that's where we're going next. Page 6. Now, page 6 is division. It's a little sing-song thing you do on division. Keep, change, flip, keep it, switch, whichever one you want to use, right? Now, with division and multiplication, it was easy, right? What's the only thing you had to do? You have to get the denominators the same like addition and subtraction? No. What do you do on multiplication and division? Just multiply straight on across, right? So keep it, switch first. There's a little twist on 1, 2, and 3. Let's see what you can do first. Do you have nothing?
Yeah, I just messed up.
That's fine. Perfect. All right, and then check your answer. Matthew put up number 6 for us. Make sure that you got that as your answer, which most of y'all did when I was walking around. Most of y'all have that as your answer. Take a minute and fix it. Take a minute and fix it if you need to, because we're moving on to page 6 in like 2 seconds. Check your answer. Take a minute and fix it if you need to. All right, so page 6, when you do keep, change, flip, right, it combines what we did all last week together. So when you do keep, change, flip, anybody want to tell me what they got for keep, change, flip?
1 plus 1 over x times negative x, x over y minus 1. Sure.
The ones in the...
1 minus 5
Huh?
1 minus 5 here.
How? Okay, no.
Is it 1 plus 1?
How do I flip it?
Hmm.
What is all of this over? 1. So it'd be 1 over 1 minus x over y, right? Okay, so let's do this. You ready? If you multiply across, you still get the same thing back. Okay? That's the whole point. You want that to be, right? To check it. We don't actually physically want to do it. We would just want to check it. Alright, so in order to fix that, you know, if that's freaking you out, let's do this instead. Okay, let's try something else. If that's freaking you out, let's do this first then. Okay, if that's freaking you out, let's not do that. I don't want to freak you out. Maybe we'll try the other way first. Maybe that'll be better for you. All right, so let's pretend like that bottom's not there. Okay, let's do it this way and see if that's better. What do you notice? Pretend like this is the only thing you have is 1 plus 1 over x. How do you add things together? Same denominator, right? So if you have 1 plus 1 over x, how do you make this 1 a fraction? How do you make it a fraction? Put it over 1, right? Now to make them the same denominator, you would multiply this by x. Very good. On top and bottom. So that would be x over x plus 1 over x, right? Are y'all okay so far? Is it easier when we do it like that instead?
Yeah, but couldn't you just, when we did the first one, couldn't you just put that whole thing over 1?
You could, but that would give you the same thing back you started with, which wouldn't do you any good. Alright, so on the bottom, let's do the bottom. You ready? Pretend like the only thing you have is the 1 minus x over y. So in order to subtract fractions, what has to happen? Common denominator, so this is over 1. So what's the common denominator between these two? Y. Very good. So you're going to multiply on top and bottom by y. So that would give you y over y minus x over y. Are y'all okay so far? It just looks a little scary, but if you look at it one thing at a time, it's not too bad.
I have a question.
Yes, dear.
Wait, we're just supposed to flip that bottom fraction
We're going to do it this way. I think this will make it easier because y'all were not lacking the other way. So we're going to do this way and see if that's easier so far. All right, so cover up the bottom, pretend like it's not there. Now that they have the same denominator, what could you do? You could physically add them, but the only thing is you can't add x plus 1, so you're just going to write it down. X plus 1 over an x, right? Y'all okay so far? Right, Mike? All right, pretend like the top's not there. Now they have the same denominator, so you can do y minus x over y. Are y'all okay? Now let's do keep, change, flip. So what would we keep? Okay. Change division and multiplication. And we would flip this one, right? So it would be y over y minus x.
And then you have to multiply the y over?
Multiply the y? What do you mean multiply the y?
Because you have common denominator.
No. We're multiplying.
So would you do like y and then parentheses x plus 1?
Very good, Brinkley. You would do y and then parentheses x plus 1. Because I'm multiplying. The easy stuff is multiplying, right? You don't have to have anything common to multiply. Then what would be the bottom? X and then y minus x. That is your answer. Very good.
Yeah, that's a lot.
You want to do it that way? Yeah, let's do it that way. I think that's easier. Yes, ma'am.
I got y over negative x. Yeah, like,
You did the exact same thing we did?
yeah, I distributed the x and the y.
Oh, you distributed?
Yeah.
I mean, you can distribute, but you can leave it like this with this one. It's not wrong to distribute, though. Yeah, that's not wrong. Yes,
Can
ma'am.
we try the other one?
Let's try it this way. Since we got it this way, let's just keep it simple, okay? All right, here we go. So let's do this. You ready? Pretend like that's not there. I've got just the top. So what could I do? Put it over 1. So 1 over 1 minus y over x. Multiply by x, top and bottom. So x over x minus y over x. And make it one big old fraction, x minus y over x. Y'all okay so far? Okay, pretend like the top's not there. Ooh, those are already fractions, right? So what could I do to make those become the same? Multiply by x on the first one. And by what on the last one? By y. Very good. So that would give you x over xy plus y over xy. Oh. Are y'all okay? All right, make it one big fraction. So it would just be x plus y over xy. Okay, now that everything's one big fraction, we can do keep, change, flip. What do you want to keep? The first one, the top, the numerator. X minus y over x. Change division to multiplication, and you're going to flip the bottom one. So it would be xy over x plus y.
Alright, so right here,
Yeah.
okay, yeah. Would you just do x parentheses x plus y, or would you do x squared plus?
No, you do not want to distribute anything yet because I see something that would cancel. So if you want to smush them, you can. Or if you see something that reduces, you can. Do you see anything that reduces? The what now? The x's, right? Why do those cancel? Because the only operation you're doing between them is multiplication and division. So they will cancel out. So that will leave you with a y in the front and an x minus y in parentheses. And then just an x plus y on the bottom. Y'all okay? You want to try the last one? Y'all try the last one. Then we got to do one more thing after that. Okay, I'll try number 3.
You're subtracting that and you can't cancel out the Not necessarily exactly the same. Okay, you'll go let x minus y plus you. They should say both x minus y should be. But unless they're exactly the same, when you're adding and subtracting, you can't.
Bless you.
Okay, so you're here. Yeah, you go. What does this one need to make it the same? C. So it should be C on top and bottom. So this is the, you have C already. C,
And then you have square. These two.
Alright, and then this one, we have C.
So you have two.
So the bottom is minus two.
All right. Gracie is going to put number 3 up there for us. You check your answers with her answer.
Yeah. You didn't teach him split. You kept this one, and then flip that one, and then something that didn't well. Come here in just a minute.
Well, I don't know if I got on them.
Checking each step with her. Do the multiply by C on the first one. Multiply by B on the second one. You get C squared minus D squared over. I can't do that. C over CD. You get so far? Okay. So on the bottom, it looks like she multiplied by C on 2. So she got D plus 2C over C.
Jeez.
Okay. Is that where you went wrong?
What? I keep writing 6s for C's.
Is that where it was then? That looks like the right answer. Actually, there's something that will reduce. I see it right here. No, I don't. Yeah, I do. Yeah, I do. Something will reduce.
C squared.
And then with subtraction and addition, they have to be exactly the same to reduce. So what's the other two operations besides subtraction and addition? Multiplication and division. Do you see anything that you can reduce that has multiplication and division?
She did.
Oh, okay. She did.
No.
I don't know.
And what you
Oh,
do?
but it was 2CD.
You see it?
Yeah.
Because you're multiplying both of those. And then you're dividing. Alright, so did y'all get C squared minus D squared over D and 2C plus D, or D plus 2? A lot of you have D plus 2C.
But wouldn't you do 2CD plus D squared and then cancel out the D squares?
No, because you're subtracting and adding. You could distribute that D and have 2CD plus D squared. But the D squared would not cancel because you're adding and subtracting.
I don't think it was one.
Yeah.
So you have a 1 on top and 1 on bottom.
Alrighty, here we go. So that is all of 8.2, ladies and gentlemen. We're going to review that tomorrow. Yes, I'm going to leave the keys for you like I always do, so you can check those. And then we need to go ahead and start section 8.4 today. So, y'all ready? Y'all need a minute? Huh? No, we're kind of skipping, we're kind of chunking some of chapter 8 because we don't have to do it all.
Okay.
I don't know. On the board it says page 8. Yes, ma'am, y'all are correct. Alright, so page 7 is a review of 8.2, and that's what y'all are going to be doing tomorrow. Okay, I'm going to leave the key for you. So, let's look at page 8. It's very different. It has been quite some time since you have done this, and you did just a tiny bit of this in Algebra 1 We did not do a lot of this, okay? So, asymptotes, yep. You learned about asymptotes in Algebra 1. Yes.
No, literally, my class, we just did.
Yes. So let's look at number 8, page 8. So, very first thing that we need to fill in is we need to learn how to find horizontal asymptotes. You ready? Get it good? New stuff. All right. So, if you have the bigger degree, ooh, what was a degree?
Exponent?
The exponent. Very good. Okay, so if the biggest exponent is in the denominator, then your horizontal asymptote is y equals 0. If the bigger degree or the bigger exponent is in the numerator, if it's in the top, there is no horizontal asymptote at all. And I'm going to explain to you why. Horizontal. Goodness, I can't spell. Alright, if they have the exact same degree, all you do is divide the coefficients. What's a coefficient? The big numbers in the front, right? Okay, so let's take a stroll down memory lane, shall we? You ready? Let's take my calculator real quick. If I'll go to y equals, give me a number, any number. 8, I heard 8. Okay, so if I have y equals 8, you might want to write this down on your side somewhere, okay? If I graph that, what kind of a line does that give me? Horizontal, right? So that means if I had, give me another number. 2. If I had x equals 2, if I have x equals a number, what kind of line is that? Vertical. Is this bringing some memories back? If it doesn't, it should, because I have taught you this. So it's opposite of the axis. So the y-axis is which way? Up and down, right? Vertical. So what's opposite of vertical? Horizontal. So if you got y equals a number, it's opposite of the axis, which is horizontal. Which way is the x-axis? Which way does it run? Left or right? Horizontal, right? What's the opposite of horizontal? So if x equals a number, it's opposite of the x-axis, so it's vertical. Are y'all okay? Got it good? All right. So where is y equals 0? What kind of an asymptote is that? Is that vertical or is that horizontal? It's at horizontal. Oh my goodness, ladies and gentlemen. If it's horizontal and it's at 0, where is that actually? The where? What is that, Sydney? The x-axis. Look at her go. Are y'all okay? Okay, here we go. Let's look at number 1. You ready? All right. All the directions say to do is find the horizontal asymptote, okay? We don't have to factor. We don't have to pull anything out. We don't have to add, subtract. So, look at the degrees. Look at the exponents. What do you notice about the exponents? They're the same. If they're the same, what do I do? Divide the coefficients. What is the coefficient right here? 1. So your horizontal asymptote, I'm just going to abbreviate, is at y equals what? Exclamation point. That's a 1, baby.
That's the one right there beside horizontal. No, beside horizontal.
It's little dots, baby.
Oh,
It's just little dots. It's a colon.
it looks like an exclamation.
No, it's a colon. Alright, so horizontal asymptote is that y equals what? Mike. 1/2, 1/2. Very good. So the hardest part about these is just remembering these 3 rules, right? Okay, let's look at number 2. What?
Sorry.
What?
So you wouldn't have to do 2 over -1 either?
No, baby, just the leading coefficients.
Oh yeah, that's...
Yep. The same degree, just divide the leading. Here, we'll put leading right here. Is that better? Leading coefficients. Alright, what about number 2? Number 2. How you know that? The highest degree is in the numerator. So, there is no horizontal asymptote.
So if we just write NA, would it buff?
No, no horizontal asymptote. Thank you, sir. You're not gonna die. You'll be okay. You'll be alright. Alright. What about number 3? What do you notice about number 3? The biggest is in the denominator. So my horizontal asymptote is where? Y equals 0. Now let's take a stroll down memory lane. Where is, or what is, an asymptote?
The one that is an imaginary line.
Yes.
That splits two lines.
It splits two different graphs and
Yeah.
they don't touch.
They don't touch. They approach the asymptote, right? Just like the median. They don't actually bounce off of it. You don't hit the median and then bounce off of it. You approach the asymptote, but you never touch it. All right, let's remember about some parent graphs. There was a parent graph that you learned in Algebra 1, and we wrote it on your parent graph page. So, what are the parent graphs that we've learned? What's one of them we learned? Y equals x, which is what kind of a line? Straight line. All right, what else have we learned?
Y equals x squared.
X squared, which is what? Parabola. What else have you learned?
Y equals absolute value.
Absolute value. Let's not, please. Absolute value of x, right? What else? And what kind of graph does that make? Makes a V, right? What else have you learned?
Y equals square root of x.
Square root of x. What was that?
The curve on the y.
Is half of a parabola. It's a curve, right? Half of a parabola turns sideways. What else have you learned?
Y equals 1 under x.
Y equals x cubed. What kind of graph was that, Matthew? Oh, nay. Right, now he's all upset because I hushed him earlier. What else have you learned?
Y equals 1 over x.
1 over x. Ooh, what is the graph of 1 over x?
It's the asymptote.
It's the one that has an asymptote, right? It's got both the curves. So this one has 2 asymptotes. Where is the first asymptote?
That y-axis.
The y-axis, which is x equals what number?
0.
0, because it's a vertical line, right? Vertical lines are x equals. What else does it have an asymptote at?
The x-axis.
The x-axis. What is the x-axis called?
Y equals 0.
Oh, no way. It has y equals 0.
Whoa,
Why does it have y equals 0?
because it doesn't touch me. Or something like that.
I get close to the
People read. Why does it have y equals 0?
Because it's
What was the degree in the denominator? What's the degree in the denominator?
1.
Where do y'all see a 3 at? It's a 1, baby. The exponent is a 1. X. We on this one. We not on that. We on this right here. Okay, so what's the degree in the denominator? 1 is the exponent, the degree. Does it have an x in the top? No, so 1 is bigger, right? It's on the bottom. Does that make sense? Let's look at, y'all wanted to look at number 3, you said? Okay. 4x squared. Oh, I didn't put parentheses. 4x squared, what, minus 2? And then what's it say?
4x
To the third?
minus
Minus 1? Okay. It's going to be crazy. It's all right. Let's wait for it. Oh, Lord have mercy. That's an ugly looking graph. Whew. That's why, now you see why I didn't use that one? All right, so here's what we're going to do. You ready?
Wait, how did you pull that in? I'm sorry.
You just use parentheses around the top, parentheses around the bottom. Divide them.
See?
All right, so here's what we're going to do tomorrow. Tomorrow, you're going to be working on page 7. Do not start on it right now. Do not start on it right now, because we're about to be finished today. And then tomorrow, you're also going to work on page 9, which is what we just did. Okay, does that make sense to everybody?
Yeah.
Not page 9. No. What page is that? Where did that go? Where did that page 9?
So you want us to pack up?
No. Oh, your study guide. Page 13. That's where it is. There we go. Page 13. All right. Here we go. If I haven't looked at your project yet, that's what we're going to be looking at real quick. So when I call you, I need you to go grab your project and bring it to me.